Okay, since most pharmaceutical reference manuals only list adult dosages, pediatricians have to be especially careful when it comes to calculating dosages for its patients. Fortunately, there are several methods to choose. When calculating how much of a particular antibiotic or medication should be prescribed to a child in its activity, we focus on one calculation method, Young's rule. So, if we have, let's say, D equals the child's dosage in milligrams, capital D equals the adult dosage in milligrams, and A equals the child's age in years, then we will have the following. Young's rule. D equals D times A over A plus 12. So we have the following problem. If a 6-year-old child takes 300 milligrams, what is the adult dosage? The first thing we have to do is substitute our information in the formula. So we have D, which is the child's age dosage in milligrams, that is equal to 300. It's equal to D times 6 over 6 plus 12, which is the same as 300 milligrams D times 6 plus 12 is 18. So this 18 we can pass it multiplying to this side. So we have 300 times 18 is equal to D times 6. This 6 we can pass it dividing because it's multiplying. So we have D is equals to 300 times 18 divided by 6, which is equal to 900 milligrams. Then we have problem B that says, suppose the adult dosage of an antibiotic is 1500 milligrams per day. Use the Young's rule to determine the corresponding children dosage for the given age. 2, 4, 6, 8, 10, and 12. Okay. To do the following, we have to do this. We need to substitute in our formula. So we have D is equal to this times 2 over 2 plus 12. So we have D is equal to 3000 over 14, which is equal to 214.28. So this is equal to 214.28. If we do the same with the different years, we will get this. If we have 4 years, we get 375. If we have 6 years, we get 500 milligrams. If we have 8 years, we have 600. If we have 10 years, we get 681.81. If we have 12, we have 750 milligrams.
Can the value of A be negative, and why? A is equal to child's age. So no, A can't be negative because you can be -1 years old. Find the limit when a approaches positive infinite and explain the meaning of this value in the context. As a approaches positive infinite, the limit is 750 milligrams. This is because if we use this table of Young's rule, we can see that the child's age limit is 12, and when a child is 12 years old, he takes 750 milligrams. After he is 12 years old, he is considered an adult. So
this is the problem that we need to solve using definition. First step, you need to put f prime of x, h approaching 0 equals 5 open parentheses x plus h minus 3 open parentheses x plus h. You need to put the square plus e. Now we change this formula, you change the sign, so it will be minus 5x plus 3x squared minus e over h. Next step, to put is h approaching 0 equals 5x plus h. Now we open parentheses, 3 parentheses x squared plus 2xh plus h squared, close parentheses, plus e, and this we copy it as equal, minus 5x plus 3x squared minus e over h. Next step, now we multiply the parentheses, so it will be 5x plus 5h minus 3x squared minus 6h plus this minus 3h squared plus e minus 5x plus 3x squared minus e over h. In this step, we will see which values we can cancel. For example, we can cancel the 5x with this minus 5x, plus 3x squared minus 3x squared, minus e plus e, and the left values we have 5h minus 6xh minus 3h squared, so we copy them over h, and as you can see we have h in common, so we're going to take 1, so it will be out of the parentheses we'll put an h, open parentheses 5 minus 6x and minus 3h, because this squared, we close parentheses over h. We can cancel these h's. In the next step, we will replace this 0 on this h, so 5 minus 6x minus 3 over 0, because h is approaching 0, so minus 3 plus 0 times 0 equals 0, so f of x approaching, it will be 5 minus 6x.